Hello there. You are early. I just started this YouTube channel about 2 weeks ago. My name is LZRS and I am an engineer and venture-backed founder. In this video, I will recap everything that I've covered so far in the life of my channel. So if you are new here, this is a perfect way to get up to speed. First, we will cover the concept of Software 2.0, coined by Karpathy. Out of all the benefits of studying AI, I believe that the Software 2 mental model is the most impactful. We will explain how it works and how it should change your worldview, even outside the realms of software development. Next, I will cover my reaction to a debate between Eliezer Yudkowsky and Stephen Wolfram. In short, I argue that Yudkowsky is wrong. AI is not going to kill us. I systematically dismantle his worldview, showing not only why his specific arguments are wrong, but also why his entire approach is flawed. Sound interesting? Let's dive in. Karpathy is one of the GOATs in AI. Previously, he led AI at Tesla and then did a stint at OpenAI, but I think he's probably best known for his AI educational content. During my live stream, I reacted to a talk that he gave in 2018 while he was working at Tesla about Software 2.0. Before explaining what that means, let's first talk about Software 1.0. In other words, traditional software. Software 1.0 is built by decomposition. In order to build traditional software, every instruction must be handwritten by a human. The problem needs to be completely understood by one person or a group of people in order to build it. AI used to be built with Software 1.0 techniques. For example, early self-driving cars had edge detection technology that allowed them to stay within the lane. Here's an example from the 80s.
Video cameras provide color and intensity images for scene interpretation. Road edges, for example, are analyzed through intensity, texture, and color segmentation. A Blackboard computer architecture integrates the distributed processes that sense, map, plan, and drive.
However, this does not scale well. Some problems are just too difficult. For example, if you wanted to build an AI that detects if there's a cat in an image, it would not be well suited to a Software 1.0 approach. Look at the incredible variation between these images of cats. But what is fundamentally different about detecting a cat and staying inside lane lines? It comes down to complexity. Distinguishing between cats and other animals is a more complex task than simply following the lane. It's easy to write the explicit logic for keeping a distance between two sides of the lane, whereas specifying exact instructions for a computer to identify what a cat is very complex. And so we get this idea of program complexity. This circle represents all possible computer software. A single point on this circle represents a single piece of software, such as the one that you're using to consume this content right now. Software 1.0 is simple and therefore occupies space toward the center of the circle. Very simple intro to computer science programs like Hello World would be near the very center, whereas complex software like databases or operating systems or compilers would be further out, but still relatively close to the center. Software 1.0 can get so complex that you need entire teams or companies to maintain them. Complex programs like ChatGPT or Tesla Autopilot would be much further out towards the perimeter of the circle. Since there's effectively no number of people or no amount of resources that you could throw together to build these programs by hand, we need a different approach. They're just too complex. And that different approach is Software 2.0. Unlike Software 1.0, which is built manually by decomposing the problem and hand coding the solutions, Software 2.0 automates the process of building software through optimization. The Software 2.0 process searches for the best solution, as you can see in the picture. Before training, the neural network is completely ineffective. But throughout the training process, it learns how to do the job effectively, hence the term machine learning. Training is an iterative process where the neural network adjusts after processing new data. If it makes a mistake, it will learn a lesson from that mistake so that it is less likely to make a mistake like that in the future. This is a slow and grueling way to make software. It involves many iterations that only improve the neural network's performance by a tiny amount each time. But luckily, we can combine many computers to speed it up by teaching it many lessons in parallel. So, after an astronomically large number of iterations, teaching it from an unfathomably large corpus of data, all of these micro improvements add up to create software that can solve the problem it was being trained for. Referring back to this picture, as you can see, the software started off at a given point and was adjusted over time through many training iterations until the optimization process found a good version of the software. Specifically, the term optimization is used because you are trying to find software that makes the fewest possible mistakes. In other words, the error is minimized. So if you're looking at a curve, be it in 2D, 3D, or higher dimensions, you will come across points that you can say that's a maximum point and a minimum point. And both a maximum point and a minimum point can also be called an optimum point. And so optimization is when you move something towards an optimum, meaning a highest or lowest value. Here are some visualizations to show how you might conceptualize an AI training a neural network. Slowly moving the error to a lower and lower value, which means that the neural network will be able to make predictions more accurately. If you want a more in-depth and technical exploration of neural networks and gradient descent, check out my video diving into AI. So looking at the long arc of AI history, not only has Software 2.0 become the key to success at Tesla, it exposes a powerful roadmap for how humans can build things never before possible. The less code that humans write, the better. The more that computers can iterate on large data sets, the better the results. This is why over time, less and less of the autopilot software at Tesla is written by humans. The AI is increasingly being trained end to end, and it's getting much better results. Now that we've covered Software 2.0, I want to make a case for you that this idea can be applied even outside the realm of AI and software. I've done a good amount of work relating this to crypto, but I don't want to get lost in the details of that. I think I can present to you some more straightforward examples for this video. Allow me to draw an analogy. Think about a startup company. What does it take for it to be successful? As Sam Altman points out, iteration speed is the #1 predictor of success. Why? Well, let's look back at the Software 2.0 graphic. Just like deep learning is searching for a program that minimizes error in the space of all programs, a startup is searching for product market fit in the space of all businesses. In deep learning, compute generally leads to better results because you can run more training iterations and hence search for longer. The same thing applies to startups. You can think of your initial idea as the starting point, and then iteration drives the search process for that optimal business model and org chart. And furthermore, business as a subject is also an optimization problem. Instead of minimizing the error from the loss function as they do in deep learning, businesses attempt to maximize profit in the market. And fundamentally, this is why markets are able to achieve things that central planning cannot. That's why people say, let the market decide. Central planning requires governance through decomposition. And as economists like Hayek and Mises point out, the world is too complex to govern this way. Not only do central planners lack information that is distributed across society, but they also lack the computational power to calculate the optimal allocation of resources. So with this toolkit in mind, I now want to shift your attention to the topic of AI doom. My view is that in their debate, Stephen Wolfram is right and Eliezer Yudkowsky is wrong. Specifically, I don't agree with Yudkowsky's claims that AI will kill us all. To preface this though, I want to introduce you to the idea of a complex system. Here is my favorite definition. Complex systems have multiple interacting components whose collective behavior cannot be simply inferred from the behavior of components. In other words, you cannot predict the behavior of a complex system by simply looking at its pieces. One obvious example of this is from economics, where microeconomics and macroeconomics are often treated as distinct fields. The difference between them being that microeconomics is on a much smaller scale, dealing with individual markets and individual economic actors, whereas macroeconomics deals with the aggregate of markets and actors across national and global economies. Despite the fact that they're both subfields of economics, the fact that they are complex and at different scales means that they're governed by different laws. Before we move on, I want to prove to you that this is not merely an abstract idea discussed by economists or statisticians. This is not some sort of esoteric theory that I'm bringing up in order to refute Yudkowsky's claims. It is at the core of almost every field and shows up time and time again in science. For example, physicist Dr. Sabine Hossenfelder believes that complexity is one of the most consequential areas to be studied in physics. Biologist Dr. Brett Weinstein explains how it's important not to confuse a complicated system with a complex system.
This is something Heather and I talk about frequently, is that we have more or less an epidemic of people who are maybe smart, but they don't know the difference between a complex system and a complicated one. And so they take their complicated system thinking into complex systems.
What is the difference?
Whether it's predictable. So, for example, your computer or your phone, it's beyond your comprehension or my comprehension, but it is well understood how it works. There's nothing mysterious about the outputs, right? It's a system that all of the functionality of is well understood. But a biological creature isn't anything like this. And so when you intervene, when they give you a drug and they think they know what it's going to do, they're intervening in a system in which things are connected in ways that they've not yet discovered, and they can't anticipate the cascading effects. So, we keep getting upended by the sense of oh, this thing is wrong with you. Here's a biochemical intervention that will adjust one parameter and put you back into health. No, almost never true, right? It is occasionally true if somebody is quite sick that you can push them back in the direction of homeostasis. You can rescue them. But the idea of improving health with an intervention is almost always the wrong approach, right? You should be restoring the environment in which the body knows how to take care of itself, because it is a complex system. Given the right inputs, given the right parameters, it has all of the processes necessary to keep it functioning. But if you think you're going to improve it by intervening, you're almost certain to do harm.
Now I hope you're getting the idea for how to think about this subject. My view is that general artificial superintelligence will be best thought of as a complex system. Remember that we are already using optimization to build software that is too complex for us to understand. ASI will be even more complex than our current systems. So the implication of AI being a complex system is that we can't predict which actions it will take. I really want to pause here to get this point across. We must apply what we know about complexity theory to this problem. Without concrete evidence, we don't know what an AI will do. I'm not saying that an AI's actions are actually random, but given that it is a complex system, it will appear random unless we have a proven model to predict its behavior. Yudkowsky claims to have such a model, but he derives this model using a priori logical deduction. And unfortunately for him, a priori logical deduction never works in the real world when predicting the behavior of complex systems. Over the years, I've seen countless supposed geniuses claim they could use clever logic to derive an ought from an is, or predict economic outcomes, or prove the existence of God. Time and time again, these arguments fall short. And every single time, they and their supporters say something along the lines of, oh, if you really read these papers on the logical arguments, you would be convinced. But in reality, it's never convincing. Logic is just fundamentally not useful in that way. The only way to make a credible statement about the behavior of a complex system is through the scientific method. Although it doesn't need to happen in a lab, there needs to be a process that collects real evidence, makes and tests predictions, and finds a statistically significant signal in the data. Without doing this, you cannot make any claims at all about the behavior of the system. So now let's be clear about Yudkowsky's position. He doesn't merely believe that AI might kill us. He believes it's almost inevitable.
And what you're saying is there is a chance that the unexpected kills us all. And
No. I expect it to systematically kill us all. I'm not being like, we don't understand it, therefore it might kill us. I'm being like, there are aspects of this that we can understand and thereby predict that it will kill us.
Okay,
I can't predict the intervening steps, but I can predict where it ends up.
Furthermore, he also clarified that he's not worried about science fiction scenarios like bad guys with AI or uncontrollable killer drones. He believes that regardless of what the AI is built to do, even if the direct goal is not to kill people, any powerful general AI, such as one built in a lab, will converge on doing so. I'm emphasizing this because I don't want anyone to interpret Yudkowsky's specific extreme claims as reasonable concerns. Everyone agrees that AI could do harm. But that's not what Yudkowsky's arguing. Before diving into the justification for Yudkowsky's position, I want to add one important qualification on the claims that he is making.
so what's your scenario for how the world ends type thing?
OpenAI builds GPT 7, 5, 14. Timing these things is much, much harder than predicting where they end up eventually. Historically, scientists have sometimes made correct calls about the future. The ones who made correct calls about the future very rarely predicted it down to the year.
This should already raise red flags. Predictions about complex systems without a timing component are almost always worthless. Allow me to illustrate with an example. There's a theorem that states, given enough time with a typewriter, even a monkey could write the complete works of Shakespeare. A corollary of this could be called the monkey with an iPhone. Given enough time, a monkey with an iPhone could hack all of the world's nuclear weapons and kill us all. Are we worried about a monkey with an iPhone? No. Do we think that we can reliably produce the complete works of Shakespeare by giving a typewriter to a monkey? Also, no. So I want you to think about Yudkowsky's arguments with this possible objection in mind. Although AI might kill us on a long enough time horizon, perhaps we can't reasonably expect it to do so in reality. Here's one more example. There's a famous quote from the movie Fight Club.
On a long enough timeline, the survival rate for everyone drops to 0.
Which of course is in line with thermodynamics, the supposed heat death of the universe, and so on. My point in saying this is that if we are not careful, we might end up accidentally restating on a long enough timeline the survival rate of everyone drops to 0 in so many words, while obfuscating it with language and imagery to make it feel like a more imminent threat than the original quote implies. Without predicting a time component, we might be systematically underestimating the timescale of these events. And in doing so, just like monkeys on a typewriter, this could make Yudkowsky's prediction completely inapplicable in the real world. So let's get to his actual arguments. Yudkowsky believes that AI will have goals. These goals will likely not be explicitly to kill all humans. AIs could have any number of possible goals, including ones that are incomprehensible to us. But in order to achieve these goals, whatever these goals are, the AI will need to accomplish sub-goals. So we really ought not become too worried about what the AI intends to do overall. What we need to worry about is what sub-goals will it come up with in order to accomplish its primary goal. Regardless of the primary goal, humans will likely not be helpful in achieving this goal. And in fact, they could potentially hurt the AI's chances of achieving it. Therefore, if an AI pursues their goal hard enough, it is almost guaranteed that killing all humans would be a sub-goal that at least marginally helps them achieve their overall goal. Let's take paperclips as an example. Is it possible that humans could hurt the AI's ability to create the maximum number of paperclips possible? Yes, it's possible. Then why wouldn't the AI take care of that problem, if you know what I mean? In fact, an AI might even need to use the atoms that humans are made of in order to make as many paperclips as possible. It may not directly care whether or not the humans survive, but as a byproduct of using their atoms, it would cause all humans to die. Although at no point in this debate was Yudkowsky's position clearly and comprehensively stated, here's a collection of clips that support my characterization of his views. Feel free to watch the whole debate or read his other works if you want to know more.
I think the term risk is understating it. If there were an asteroid straight on course for Earth, we wouldn't call that asteroid risk. We'd call that impending asteroid ruin. We're on course to get something smarter than us, whose innards we don't understand, which we cannot very well control. And this probably ends quite poorly. The thing that we can hypothesize is this thing's actions will end up leading to a certain endpoint. We might not even know the trajectory it's going to take to get there. If we don't know the details of the mountain, the rock's choices may be things that we don't understand even after seeing them. But we may still be able to predict that the sentient rock ends up at the bottom of the mountain. The stuff that is predicting which actions are needed to get to which end states is the dangerous stuff. The stuff that is figuring out which actions are needed to steer those facts to being different in the future.
Right, but
that's
these are
the dangerous
observations.
stuff.
You're asserting is that many of the things that will happen are things which will kill us, basically. And
I'm
I don't
expecting it to
get
get
that.
better and better at planning, better and better at strategy, better and better at invention, but not to end up very precisely, like so precisely aligned that there's even room in its world for humans, fun, consciousness, people caring about each other, that sort of thing.
But
most goals tangled up in the real world are like that. If you want to make as many paperclips as possible, if you want to make as many staples as possible, if you want to make as many giant cheesecakes as possible, if you want to make as many intricate mechanical clocks as possible, you use the atoms that are making up the humans, you intercept all of the sunlight using a Dyson sphere, and you don't particularly leave sunlight for the humans. Most goals, if you go hard on them, imply no more humans.
So let's assume, for the sake of argument, that Yudkowsky's logic is sound. AI will have some goal, and in order to achieve it, will kill all humans. There's a real debate to be had over if most possible goals converge on this sub-goal, but I don't want to go down that rabbit hole. Even if this logic is sound, the way he applies it in his argument ignores important concepts such as time preference, trade-offs, and diminishing returns. Allow me to explain. Diminishing returns is a phenomena by which, as you put more into a system, at some point, you start getting less and less out. So, for example, I've been working on this video for about 3 days, and I've made a lot of progress. I could continue working on this video for the rest of my life. But at some point, continuing to edit and rewrite it would stop making it much better. I could spend years for only a marginal increase in this video's quality. Furthermore, if I get hit by a bus tomorrow, the fact that I didn't release the video today would have prevented me from having any video at all, regardless of how good it is. Failure to publish would put the entire goal in jeopardy. Sure, humans could get in the way of an AI that wants to make as many paperclips as possible. But is killing them really the highest ROI activity? What about eliminating the great apes so they don't eventually evolve into humans again? Or maybe we should also eliminate all the shrews. Why not? Is there no better use of resources, such as researching new ways to mass produce paperclips? How are these decisions made? Despite its immense intelligence, AI is not post-scarcity. It must make trade-offs when allocating resources. It can't do everything. Let's think about some scenarios. If AI is only marginally more capable than humanity as a whole, isn't there a chance, due to stochasticity, that fighting could end in defeat? how does that affect the probability of success? Is that worth it for the AI? And if AI is far smarter than humanity, why should crushing humanity be a priority? It could do it at any time if needed. The point I'm making here is that killing humans might be a logical subgoal of AI. However, there is no evidence to believe that it will actually get around to it. Again, we are coming back to the issue of ignoring timing in this argument. Yes, eventually an unlimited scaling AI on a long enough time horizon would kill all humans. But on a long enough time horizon, we will die from a variety of other causes anyway. So the odds of AI being the culprit approaches zero. And it's important that I re-emphasize that AI is also subjected to natural forces in the universe. It is not omnipotent. It is not omniscient. It is not a god. It must contend with entropy, which introduces uncertainty about the future. Entropy causes uncertainty to build as you predict the future further and further out. Therefore, although the AI might think on timescales longer than humans, it will have some timescale upon which it will try to achieve its goals in order to obtain a maximum expected value. Unless humans are likely to get in the way within that timescale, there's no reason that the AI would kill all of them. In fact, it seems to me that entropy and the laws of nature are a much greater threat to the AI than humans. Yudkowsky is framing this as PvP, when in fact it's really PvE. AI, like humans, is not immortal, it is not omniscient, it is not omnipotent, it is not a god. I know that Yudkowsky claims that he doesn't believe AI is a god. However, by assuming unbounded scaling across an unlimited timescale, he effectively is. Now, I fully expect people to accuse me of nitpicking here. People might say that I'm trying to find problems in his argument rather than understanding the big picture of what he's trying to say. This is not my intention. I am merely showing why none of the arguments that he makes convince me that we can predict the behavior of AI. Stephen Wolfram was also not convinced. After getting pressed on this in the debate, Yudkowsky admits that his arguments are not airtight and instead falls back on an intuition-based argument.
What you're saying is that, we can't do the calculations for AIs, and you're saying, or you think you have done the calculations for AIs, and they will ignite the atmosphere.
Yeah, back of the envelope. This is not like a rigorous calculation, and it's not going to be a rigorous calculation before the world ends, because this is more like tangled up biochemistry and less like straightforward physics.
So the concern is your back of the envelope calculation says AIs will do the analog of ignite the atmosphere, and I guess one feature of back of the envelope calculations is they require intuition. They're not things where you can, if you do some very rigorous thing with axioms and you can go step by step, it doesn't really matter if you have good intuition or not. It's just mechanical. But back of the envelope requires intuition.
Good thing that reality, since the moment of its dawn, has followed a hard and fast rule. If you cannot do rigorous formal calculations about something, it is not allowed to kill you. Just nobody in the history of time has ever once had a cause of death that required intuition to understand.
This is a deeply flawed perspective. And to show you why, I will make 2 points. The first, research into intuitions shows that they are not reliable unless you have experience with the thing you are having an intuition about. The book Thinking Fast and Slow details this. I recommend checking it out. Now, the second insight is also in part from the book Thinking Fast and Slow. And it's that cognitive biases often give us false intuitions. But is Yudkowsky falling prey to cognitive biases here? I thought you'd never ask. In fact, he is a textbook case of someone being affected by cognitive biases that are known to produce superstitious beliefs. In order to explain this, we must look to the cognitive science of religion. A huge percentage of people throughout history had religious beliefs. Is this by chance? Or is there an evolutionary reason for it? The scientific consensus is overwhelmingly in the camp that humans have cognitive biases that cause them to be religious. To be clear, this does not mean that your religion of choice is untrue. It just means that humans are wired to believe it, whether or not it's true. So, what are the cognitive biases that cause people to be religious? Cognitive scientists believe that religious beliefs result from a combination of hyperactive agency detection, promiscuous teleology, and dualism stemming from the theory of mind.
In the next few lectures, we're going to talk about certain features of the human mind that draw it towards religion and in some ways constrain the types of religious beliefs that emerge. For instance, we'll talk about something called the hyperactive agency detection device, which is a feature of the human mind that evolved to allow us to better detect predators and prey out in the world, but as a consequence has led us to overperceive agency where there is none. We'll also talk about the tendency to overperceive purpose and goal states out in the world, something which turns us all into little intuitive creationists. And we'll talk about the existential fears that underlie the human condition, that draw us towards the soft, comforting bosom of religion. But right now, I want to talk more about mind-body dualism. So humans are fundamentally social creatures. That's one of the features that has led us to so completely diverge from the other animals that we share the planet with. In just the last few million years, our brains have undergone a massive amount of evolutionary change to enable us to better navigate an increasingly complex social world. As a result, we have many mental adaptations to allow us to better understand other people's minds, to be able to predict their behavior, to understand their goal states. And these abilities together are what psychologists call theory of mind. The developmental psychologist Paul Bloom, who we talked about a little earlier, has argued that our system for understanding mental states is fundamentally separate from the system we use to understand physical objects. And for evidence, he points to some research from his own lab with babies, where he shows that babies react very differently when physical objects violate the laws of physics compared to when people do.
Hyperactive agency detection is, at its core, an irrational fear that an intelligent agent is going to kill us, even when there is no evidence to support it. Yes, there's literally a cognitive bias for that concern. So that's why when you hear a sound in the other room and you are scared and you say, "Who's there?" and all of that, it's usually not a serial killer. It's usually not a wild animal. Something just fell off the table, but you're still concerned. And this is often paired with what's called promiscuous teleology, which is the tendency to project goals onto systems that probably shouldn't be thought of as having goals. And what's interesting is that I would estimate about 30% of the debate between Yudkowsky and Wolfram centered around teleology. Without going too deep down that rabbit hole, Wolfram and I remained unconvinced. But my point is that I want you to notice how much of Yudkowsky's worldview hinges on specific assumptions around AI having goals and acting with purpose. And it just so happens that people who are falling prey to hyperactive agency detection often also fall prey to promiscuous teleology, where they think about systems as having goals that are not well modeled with that framework. Another important cognitive feature that humans have is theory of mind. When we think about purpose-driven agents, we have a model for how that would work based on what we believe the human mind would do. Perhaps I can tell that you're having a bad day and I decide to give you a compliment. Theory of mind could be useful for me in that context, because I understand the emotions that a human could be going through and what they might respond to. However, seeing bad weather and giving a compliment or saying a prayer to the weather god would likely not be a particularly effective way of changing the weather. And this is not just, there's not just the risk of misapplying theory of mind when you also have hyperactive agency detection and promiscuous teleology. There's also other cognitive biases that strongly correlate to theory of mind that stem from dualism. And The one I want to mention in particular is the assumption that minds and souls are immortal. In other words, they operate on an unlimited timescale, and they are not constrained by natural forces in the physical world. Now, I'm sure you can see how each of these biases shape Yudkowsky's worldview in various instances. But I really want to also emphasize that the combined effects of all of these are also well studied and documented. Together, these biases consistently produce superstitious, mythical, and religious-like beliefs that are strongly held, often apocalyptic, and not based on evidence. To recap, Yudkowsky assumes that AI is a purpose-driven agent acting on an unlimited timescale. By doing this, he ignores the constraints posed by the universe, like entropy, leading to uncertainty about the future. He also makes claims that AI could use all the atoms and assumes the AI would not self-destruct or halt. If this is not effectively omniscience and omnipotence, I don't know what is. Just like many religious apologists have proven God's existence with logic, he also uses logical arguments that are admittedly not airtight as his only evidence for the claim that AI will kill us. In the end, he falls back to intuition. But it turns out that his entire worldview lines up exactly with the byproduct of cognitive biases that distort intuition. Now, as a final exercise, I want to demonstrate the superior expository power of my worldview over Yudkowsky's. Let's think about the question that he raised.
There are unintended things that will happen in the AI. I think there are unintended things that happen as you try and tighten up this argument. That is my claim.
Well, why didn't the conclusion I would end with is like, you can imagine the Native Americans trying really hard to come up with arguments why, like, the ships they see approaching can't possibly hurt them, like, well, what could they want? Can we really define a language over what they want? Maybe most things that they want have us be alive. And these people were in a much more favorable situation that they would have had a much easier time of retrieving.
Should the Native Americans have been afraid when they saw European ships? They shouldn't have had a PDUM of 99%, but yes, they should have been concerned. But how could they have known this if we're not supposed to use a priori logic to predict the actions of complex systems? Well, the answer is something we've already covered. Theory of mind. They know that humans are likely to fight with other humans over human resources. Theory of mind is an acceptable model for predicting the behavior of certain complex systems, specifically the actions of individual humans and groups of humans. Evolution ran a search for the most predictive model of human behavior. It formulated hypotheses, tested them with real evidence, and extracted signal from the data. Those with more accurate theories of mind survived, while those with less predictive versions didn't. Theory of mind can predict the actions of humans. It can also predict threats such as humans weaponizing AI, but it cannot predict things like weather patterns or the actions that a general AI will take. For that, we need evidence, and we need far better evidence than was provided by Yudkowsky. So if you have such evidence, please let me know. But until then, I remain unconvinced. Thank you to everyone who watched to the end. If you thought this was entertaining and information dense, I highly recommend subscribing. And please like the video to help with the algorithm. All of this content is just a recap of 9 live stream videos. Think about how much we can cover if you tune in consistently over the next year. Every weekday, I do an hour-plus live stream covering content like this. If you want something entertaining and educational that's always available for you to listen to, please join me on this journey. In upcoming episodes, I will dive deeper into crypto, both cryptocurrency and cryptography. I'll also talk about structural problems in financial markets. And of course, I'll cover a lot more AI-related topics. Leave a comment below with topics you would like me to cover. I'm open to anything at the intersection of tech and society. Have a wonderful 2025.